Intermediate Algebra for Statistics, Using Substitution to Solve Systems, Part 2. Lesson Objectives: Use substitution to solve systems of linear equations. Solve inconsistent and dependent systems by substitution. Example 2. Solve the systems x minus 3y equals 4, 2x minus 5y equals 5. So if you recall, the first step is we have to pick an equation and either solve for x or y. The easiest equation to use would be the first equation and solve for x. The reason why that is this has a coefficient of 1. So when we have a choice, we want to solve for the variable that has a coefficient of 1. If we can do this, this ensures that we will stay away from fractions. So we're going to solve for x in equation 1. So our first step is we add 3y to both sides. So we're left with x equals 3y plus 4. So we're going to take this expression, 3y plus 4, and we're going to substitute that into the other equation everywhere we see an x. So equation 2 is 2x minus 5y equals 5. So now, substituting for x, we have 2 times 3y plus 4 minus 5y equals 5. So we have one equation that has only one variable, y. Using the distributive property, we have 6y plus 8 minus 5y equals 5. Now combine like terms. 6y plus a negative 5y gives us 1y plus 8 equals 5. Now subtracting 8 from both sides, we have y is equal to a negative 3. So our next step is to take either original equation, and everywhere we see a y, we substitute negative 3. So using the first equation, we have x equals 3y plus 4, which becomes x equals 3 times negative 3 plus 4. Multiplying, we get negative 9. Negative 9 plus 4 is negative 5. So we write the solution. Remember, x always comes first. Negative 5, comma, negative 3. To verify the solution, we need to check it for both equations. So x is a negative 5, y is a negative 3. So for the first equation, on the left hand side we have negative 5 minus 3 times negative 3. Hopefully that equals 4. We have to multiply first. This becomes a positive 9. Bring down your negative 5. And negative 5 plus 9 is 4. So the left hand side equals the right hand side. It's checked. Second equation. So now we have 2 times negative 5 minus 5 times negative 3. And that should equal 5. We have to multiply first, so this becomes negative 10. Negative 5 times a negative 3 is positive 15. And we have 5 equals 5. The left hand side equals the right hand side, so it's checked. So we have verified the solution. Lesson objective number 2. Example 3. Consider the linear system y equals 2x plus 1, y equals 2x plus 3. If we substitute 2x plus 1 for y into the second equation and solve for x, we have 2x plus 1 equals 2x plus 3. We have x's on both sides, so subtracting 2x to both sides, we are left with 1 equals 3. So the x's have canceled. This is a false statement. This means no matter what the x that we use for this equation, it will always yield a false statement. So there's no solution. Inconsistent system of two equations. Property: if the result of applying substitution to a linear system of two equations is a false statement, the system is inconsistent. That is, the solution set is the empty set. There is no solution. Graphically, this happens when we have two parallel lines. Example 4. In the example below, the system y equals 2x plus 1 and 6x minus 3y equals negative 3 is dependent, and that the solution set is the infinite set of solutions of the equation y equals 2x plus 1. What happens when we solve the system by substitution? So it turns out that this equation and this equation is exactly the same equation. If we put this in y equals mx plus b form, we're going to get y equals 2x plus 1. So this has an infinite number of solutions. We call this a dependent system. Now, what would it look like if we use substitution to solve this system? So if we substitute 2x plus 1 from the first equation and substitute that into the second equation and solve for x, it would look like this. So now we have to distribute. So we are left with 6x minus 3 equals negative 3. Combining like terms, 6x minus 6x is 0x. So we're left with negative 3 equals a negative 3. Now this is a true statement, so it doesn't matter what x is, we're always going to have a true statement. Negative 3 equals negative 3. So whenever we have a dependent system, we're always going to be left with a true statement. Dependent systems of two linear equations. Property. If the result of applying substitution to a linear system of two equations is a true statement, one that can be put in the form a equals a, then the system is dependent. That is, the solution is the set of order pairs represented by every point that's on the same line. So if we think of this graphically, we would have two equations that's the same line. So whatever order pair is on the first line, it will be on the second line. Example 5. Solve the system y equals 4x minus 8 and y equals 2x plus 10. Our first step is we want to identify the equation that has an x or y that is isolated. So here either equation will do. So to solve this system, I'm going to take the first equation and substitute 4x minus 8 into the second equation. So this gives me the equation 4x minus 8 equals 2x plus 10. We have x's on both sides, so I'm going to subtract 2x to both sides. That gives me 2x minus 8 equals 10. Add 8 to both sides, we have 2x equals 18, and dividing by 2 we see that x is equal to 9. Now next, solving for y, I could take either equation. I'm going to take the first, and everywhere I see an x, I'm going to substitute a 9. So we have y equals 4 times 9 minus 8. This gives us 36 minus 8, which is 28. So we have the solution 9, 28. So if we were to graph these two equations, they would intersect at 9, 28. To verify this, we take the first equation. Wherever we see a y, we stick 28. Wherever we see an x, we stick 9. The left hand side is 28. The right hand side is 4 times 9 minus 8, which becomes 36 minus 8. So we have 28 equals 28. It checks. For the second equation, we have 28 equals 2 times 9 plus 10. Multiplying, we get 18 plus 10 on the right hand side, and of course that's 28. So it checks here. So we have verified the solution. Thanks for watching.